My name is Grant Fritchie. I work for Redgate Software. This is my contact information. If you've got questions after today, I want to try to help. So please reach out, get in touch. I will do what I can to answer any questions on this topic or any of the other ones that we've gone over today, at least any of the ones that I know anything about. If I don't know anything about it, I will find you the right person to talk to, I promise. Anyway, let's get going. Our goals here are really simple. I want to answer questions with extended events. This is not one of my traditional presentations. Easiest way to put it, I'm just going to ask a series of questions and I'm going to try to answer it with extended events, and that's it. We're just going to play a lot with code. We're going to work through this stuff. I'm not going to explain to you, well, this is how extended events work and this is how I would use it for this situation. And we're just not doing that. We're just going to answer some questions. Let's answer questions, because really, what do you need at the end of the day? Answers to your questions. So let's get answers to your questions, okay? Next slide. Can I identify long-running queries using extended events? Well, let's switch over. Where is it? Start screen sharing. Screen 2, share. All right, now I know this takes a second or two to come up. So in just a minute or two, you will see Management Studio. And yes, I'm doing everything in Management Studio, not ADS. As much as I love ADS, there's just a bunch of work that it doesn't support well, so I'm still doing it here. It looks like it's coming up, and there we go. Awesome. All right, so let's start answering questions. Can we identify long-running query? All right, so what we're going to do is set up a scenario and generate a long-running query. So I'm going to insert a value into the error log, and then I'm going to update that error log, all within a transaction. Meanwhile, back at the ranch, I'm going to start another transaction so that I'm going to have a long-running query. Now, we're going to take a second or two here to let the query run long so we can begin to see what's going on. So the goals today are not to drill into lots and lots of how-tos with the extended events necessarily, although we are going to cover them in a lot of detail. What we're doing, though, is focusing on the places where extended events helps, the things it does either that you can't do easily elsewhere, or the things you can't do at all elsewhere, or just the stuff that it's kind of fun to do it here just because it's a little bit different and a little bit more interesting. And so we're letting this query run for a little bit. We're at 45 seconds. We're going to let it just run for another couple of seconds just to make sure. So let's go back to here. That one's finished. Let's go ahead and roll it back. And then this one's going to complete, but we're going to go ahead and roll it back as well. Meanwhile, behind me, I've been letting the System Health live data window run. So System Health is running on all your systems 2008 and up right now. And one of the events that's running on System Health on your machines right now is the wait info system event, System Health event. And what it's doing is any query that runs longer than about 30 seconds, it will capture the wait information about that query. So in this case, if we go down here and take a look, we can see the query that I had was running long, and it did run long. Come on, hurry up. And it was the update statement that we ran. It ran really long time because it was waiting on the other query, which was in an open transaction and hadn't committed. Once we rolled back the transaction, this query finished, and sure enough, it then fired off this event. So the question that we have, let me zoom back out. So the question that we have is, come on. There we go. The question is can we identify a long-running query in extended events? And the simple answer is not only can you identify a long-running query inside of extended events, but you can identify long-running queries even though you didn't have an extended event session set up to capture query metrics. Hoo-ah! Yeah, now that's pretty cool, right? So what else can we do with extended events? Can we identify which query is using the most CPU? Okay, great question. Let me go over here to PowerShell and get off my screen. We've got a little PowerShell script I'm running here. Let's make sure it kicks off. There it goes. All right. So that's running a whole bunch of queries. And now I'm going to kick off a query performance extended events session. And one of the things I do love about extended events is the fact that I've got all of these different sessions set up, and all I have to do is turn them on and off. I don't have to recreate them every time I want to use them. I just start them up and then off I go. Further, when I turn on the live data, it's going to show me the information going by my screen, and it's going to remember the layout that I've given to the live data window, and then ta-da, there goes all the stuff going by. And so the question was, can we identify the query that used the most CPU? Well, let's find out. So it's run, so far it's captured another 100 events. We could let it keep running. It'll capture more and more and more over time, but we're going to stop it for the moment. So what we're going to do is not stop the session. We're going to stop the live data, and it's got 164 events now. So let's see which query had the most CPU time. Sure enough, there it is. Now, what did I just do? Well, I had a session that's capturing data, and we'll go and take a look at that in just a second. So it's capturing data. It's capturing RPC complete and SQL batch complete. I'm running a series of stored procedures from this PowerShell script, and it ran and successfully completed, and it did capture the information that I needed captured. But the question was, what had the most CPU time? So here's what I did. All I did was set up this session. Let's take a look at it. Properties. And it's still running, by the way, so we can't modify it. While it's running, you can't make changes to it. Let's go to the events. My poor little machine is crawling now between live hosting this stuff, OBS Studio to manage it all, and then running PowerShell script that's running queries nonstop. My poor little machine is dying. All right. So I've just got these two events, RPC completed and SQL batch completed. They are just capturing information based on the AdventureWorks database. So we're capturing stuff in the AdventureWorks database. There's nothing special here. It's just I set up the sessions. Once the sessions are set up, for any given event, it's capturing this information. Again, nothing extra I have to do. But if I want to identify CPU time, I want to right-click down here in CPU, make sure that I've got that show column and table enabled, and I can't enable it now because it's already there, but make sure that I've got that column in the table. And then once I'm up here, all I have to do is if I'm watching live data, pause it, or if I'm looking at a file, I don't have to do anything. I can open up a file in here and start manipulating it. But the one thing I did was I clicked on this. I clicked on the CPU column, and that's ordering the data really quickly, and so I can identify the query that had the most CPU. And that's it. It's that easy. It's that simple to start answering questions inside of extended events. That's all it does. Now let's take a look at another question. And by the way, feel free to toss a question in there. I can't promise you I'll throw an extended event session together in no time, but I will try to answer them. All right, so we answered the question, which extended event used the most CPU? So, is there a way to see the stored procedure parameter values? Now, I have been told reliably that, well, extended events won't show you the parameter values inside of stored procedures. And I'm like, oh, wow, God, that's a problem, right? I mean, because you need to see what's going on with extended events. So let's take a look. Let's switch back over to here. I'm going to reset so we're capturing the live data again. So we'll see the queries going by here in just a second, because everything's running. There it goes. Cool. So SQL batch, connection reset, and all this fun stuff going by. Let's pause it again. Let's stop. And again, this is stopping the live data. This is not stopping the session itself. The session itself is continuing to run and continuing to collect data. But I've stopped this. So let's take a look. RPC completed. Now it has an object name. And in the object name, and I will zoom in and show you, it does not have the parameters and the parameter values. So if this is what you look at, you're going to immediately go, oh my God, extended events sucks. Why would we use this? It doesn't give me the information I need. But if we notice, we've also got, in addition to the object name, we also have the statement. The statement itself has, what's that? Parameter values. Yes. In fact, can you capture the parameter values inside of extended events? And the short answer is yes. Yes, you can. It's built right in. It's part of the process. I think what happened is that in 2008, when the original version of extended events came out, I think that either it didn't capture them, or there was some confusion over which session to use, and some of the sessions don't capture them. But the basic RPC completed, remote procedure call completed, same one as you would run in Trace, it captures the values. I mean, so you've got the stored procedure values. So you can see that for 1016, it ran in 486 microseconds. It had 12 logical reads, and the CPU time was 1,000 of whatever the CPU time is. I forget, milliseconds or ticks or whatever. Anyway, you can see that we can answer that question. So, ta-da. Okay, let's look at another question. Can we filter on stored procedure names? I don't know. Can we filter on stored procedure names? Long-running query, most CPU parameter values. Right. Sorry, I'm just checking my notes because I have so many moving parts here. I want to make sure I'm running the right demo for the right procedure. So we're going to stop that. Cool. And we're going to start this one. Cool. Different demos are doing different things, so we just need to make sure we capture them correctly. So now we'll stop this and turn off the query performance. And we're going to turn on this one and this one. So the reason we're doing that is, let's watch the live data again. And remember, the live data window is going to remember the columns I picked, and it's going to relay them back out. And you can take that same column selection and share it amongst your team, put it in a central location, and it'll open it up from there, or do whatever other thing you want to do. Let's make sure my thing is running. Oh, it's not running yet because I haven't logged in. Cool. Now it's going. How do I know it's going? Because it would have errored by now. Cool. So we should be seeing the procs come up. There we go. So notice, address by city. Let's take a look at the extended events. Stored procedure name. Take a look at the properties. Take a look at the event. Again, sorry, apologies for overloading my system, running too many things at once. There it goes. Awesome. And so in this case, I'm getting RPC completed and RPC starting, both. And one thing I am doing with them is on the global fields, I've added one action. I'm very cautious about actions when I'm using extended events, just so you know, because actions, even though they're called global fields, and global field sounds magical, They are actions, meaning some of them have added overhead. So you want to be cautious about applying them just willy-nilly everywhere. But in this case, I have put on database name just so I can capture that event. And I've got a simple filter. And the filter is object name, because both of these events have the object name. And then the value is address by city. So yes, I can in fact filter by address by city. Now the only issue we have is if you have the same name running in more than one location, what happens? Well, I've got the extra little bit here running. Let's go ahead and look at the properties on this one. Because you can have this same store procedure name in multiple databases, what I have done is I've also got an extended event session that's further filtering by database to ensure that I don't accidentally run more than one thing. So if we take a look at the configuration here, and again, RPC completed and RPC starting, just so you can see both. Come on, why are you giving me a hard time? There it goes. Silly thing. We filter by the name and the database name. So you can, hang on, let me just widen this out and you can see it. And yeah, I do find the GUI a little bit of a pain in the bottom, but it's functional. It gets the job done. So you can see I go by object name and by database name. Now, the question that's going to come up on this is, does the order of these matter? And the short answer is yes, it resolves them in order. So it's going to resolve object name first and then database name second. Normally, you're going to want to put the most restrictive filter first. Think about it almost like indexing. The more restrictive index first, the more restrictive column first, the column that's going to be more interesting to the optimizer first, even though this isn't an optimization thing. It's just data elimination. The one that eliminates the most data first and then the second one second. So probably the object name is more restrictive in most cases than the database name, and therefore by filtering by object name and then database, it's probably more efficient. But testing is your buddy, and you're probably going to want to measure to see which one of these affects which. Now let's pause here a second before I answer more questions to see if there are questions. And there are. Ooh. Several.
Yeah, there's a few questions. So let's see. Let's start with the PaaS one, Grant. Right. How about the extended events for like RDS PaaS or Azure SQL Database?
Cool. PaaS, Azure SQL Database. There is one way you can capture query metrics other than either using the DMVs or Query Store. There's one way you can capture query metrics. You cannot, inside of Azure SQL Database, use Profiler. You must use extended events. Ta-da. Yes. Does it work in AWS? Sadly, not at this point, but I do know that they are working on it. They recognize the need, and Amazon should have it in there. I don't know when. I don't have any inside knowledge to tell you, but sooner rather than later, I hope. So yeah, it does work with Azure SQL Database. In fact, it's the only way to get this kind of granular data. So yeah, you've got to do that. All right, what's the next one?
All right, can you find out if a table or column is being accessed?
Do I have that?
They can find references in the current database, but if it's cross-DB or link server, is there a way to check that?
Okay, so cross-DB and link server is harder because both of them transfer some of the action to that other location. Now, from a cross-DB inside of extended events, no, it's fine. You're going to be able to track anything down. Can you look at for a particular table or for a particular column? And the short answer is yes, but there's details around that. Am I doing that one? Query most used. No, I don't have that specific question in a demo today. But can you do that? Yeah, you can. The issue that you run into is twofold. One, if you're looking for a table or a column and you're getting nothing but RPC completed, how can you tell what's been accessed? Well, from here, you can't. So what you would have to do is identify the procedures you would yourself have to identify the procedures that are accessing that table and or column, and then capture those procedures, filter by the database, or the database name, the object name, as I did here. Or in a batch situation, you can just look at the batch text itself for the table name or the column, and off you go. You're good to go. So that should answer that one.
Okay.
But again, cross database cross database is fine. Linked servers, you won't be able to tell because that query is occurring someplace else. So you would need to set up an extended event session at the link server location.
Okay. So this one, I'm not 100% sure what they mean, but I'm just going to read it. So it says the RPC completed one captures the values, but does that get triggered if you run the query from within SSMS?
Okay, that's a great question because it depends on how you're making the call. RPC completed is for remote procedure call. If you run it from within SSMS, which is why I'm avoiding it, by the way, it's not a remote procedure call, it's a batch. And if you run it as a batch, it won't show up in RPC completed, but it will show up in batch completed. So it's just all a question of capturing the right thing for the right reasons.
Okay. Somebody's asking about elastic pools in Azure. So they have a limit on DTUs. Can they get information from extended events? If they have enough DTUs configured?
I don't know. That one we will have to follow up on. I don't have a good answer.
Okay.
I wish I did. That's a great question. Thank you. But I don't know.
And the last one is deadlock analysis. Are you doing a demo showing deadlock analysis?
I might show deadlocks. We might get the deadlocks. No promises.
Okay. All right. Otherwise, that's it. You can keep going.
Okay, cool. Let's keep going. Let me find my slides again. All right. Can we audit changes to the database? Can we keep track of database stuff like not objects, not tables, not queries? Can we track database changes? Let me just look at my notes. Right. Apologies for having to look at the notes, but I just want to make sure I get the demos right. All right, so let's turn this off. Let's also stop my script. Oops. Where'd that go? There it is. Let's stop the script for the moment, just to cut down the load on the system. We will also turn off these. Just bear with me 1 second. I've just got so many of these, I don't want to run them all at the same time because it will cause problems. Let's take a look at this session called Database Behavior. We'll take a look at the properties. And what I've done is I've put together a whole bunch of different events that are available to us inside here that track database behavior specifically. And some of these are unique to extended events. They're not available, period, in Trace. So we've got alter database, we've got database attached, we've got database created, database detached, database dropped, data file size change, and yes, that includes automatic file growth, database recovery times, database recovery trace, database started, database stopped, bulk copy, log file size change, and yes, that includes automated log file changes, log growth, log shrink, log truncate. Can we track database changes? Yes. Yes, we can. We can track a lot more database changes than we can in any other way. The session's going. Let's watch live data. Let's go ahead and close this one. We don't need him now. And let's go to here. And we're going to run a really simple command. Oh, and by the way, while this was running in the background, database recovery has been firing off, all kinds of extra auditing is going on, and we should see the database, there it is, database created. So the database created, ran, we get the activity ID and the database name that was created. And so we can see each of these things that are occurring. And yes, it's firing off all of these events. So log files, size used or changed, recovery, trace, firing off. All of this stuff is going off in real time. Nothing I have to do to set this up. I mean, it's off and running. And then if we create drop database, it's going to be the same. Once again, we're going to get, there it goes. Database stopped. So we see that the database was stopped, and then we see that the database was dropped. And so each one of these commands is answering the question, can we audit database level stuff? And the simple answer is, yeah, we can. So hang on. What other questions have we got? Implicit conversions. Now, implicit conversions are a pain in the bottom, right? It just becomes an issue because it's kind of a hidden performance hit, potentially. Not always, not guaranteed, but it can be. Can we see implicit conversions occurring inside of our queries? I'm sure you already know the answer to that question is yes, but the question is how can we see it? So what we're going to do here is stop that live data. Go ahead and stop that session. Probably ought to script the session starts and stops. That would be faster, wouldn't it? And let's see, implicit conversion. So I've got this running two different ways. So we're going to fire these up. Come on. Cool. Both sessions are running. And then we will watch live data on both sessions. So let's go back to our queries. And so I've got a really simple query, and it does in fact fire off an implicit conversion, but it does it in an odd way. Let's run the query. And yeah, you can already see down here in the comments, we're going to be doing deadlocks, promise. So let's see, implicit conversion. So what I've got here is a series of events, and one of the events is a plan affecting convert. Okay, we see that there. And then it tells us what it is that caused the problem. And in this case, it's converting in varchar 23. So there is a conversion process occurring in varchar 23 sales order ID. Well, hang on, let's go back to the query for a second. And like I said, because this is where things get fun. Did I query against the sales order ID? Well, I did do a join between sales order header and sales order detail, bringing up the query ID, but it's an int. As you can see, oh, SQL prompt, come on, how can you get away from it? SQL prompt showing me that it's an int column in the sales order detail table and that it is an int column in the sales order header table. So the conversion did not occur here. So where are we getting a conversion from? Well, let's take a look at the execution plan. Did you think I was going to do a session that had no execution plans? Come on. Come on. So with the exec plan captured, even it is giving us a warning that there's a plan affecting convert. And it is letting us know that it's in the type expression convert in varchar 23. Well, we already know that from the extended event. The extended event told us what was happening. So where is this occurring? Well, happens to be I know that it's one of the two compute scalar operations, isn't it? Could have swore. Hang on. Look at the properties. This is it, yeah. So what's this thing doing? Well, it's creating, it's a calculated, it's a calculated column. So it's calculating based on these things and putting together the header number with a text, and it's combining the two. Well, that's not going to cause me problems in the query unless I'm filtering on that column. So this is actually a false positive in terms of implicit conversions coming up. Now, I want to point out that the way I did this one was I've got SQL batch starting, SQL batch completed, and the plan affecting convert event. This is actually a fairly complicated way to capture this. I've got another one running that captures it in a much simpler fashion. What I'm doing here is, let's take a look at the actual session. In this case, I've cheated a little bit. And instead of capturing a lot of different events, I've reduced my overhead quite a bit. Because again, the observer effect is real. The more of these things you turn on, the more it's going to affect your production machines. You can't just turn these on willy-nilly and everything will be fine. You do have to kind of think it through, put good filtering in place, and ensure that you're running them only when you need to, stuff like that. But so I've got the plan affecting a convert, which occurs when a type convert affects the issue. And that can be whether it's an implicit convert or an explicit convert. In this case, it's an implicit convert. Let's go and look at what I did to cheat. Because if we look at the event fields for this, all it captures is the compile time, the issue, and then the expression. So when did this happen? Why did it happen? And what was it? That's all it tells us. It doesn't tell us the query. And you kind of want to know the query, right? To track down the problem, you need to know where the query is. So what did I do? Well, again, I've used actions to add one. And in this case, it's SQL text. So what I'm doing is I've added in the text. So it will capture the text of the query at the point of the explicit conversion. And so we can see that all in action up here. Let's close this so it's out of our way. We can see up here that we've got the text and the explicit conversion. And then just as before, the expression is available to us as well. So we're not losing any data. We're simply capturing one event instead of two and adding in the text so that we're, yes, a little bit of overhead, but not as much as capturing multiple events. So it's just a way to kind of explore the means around what you can do with extended events, because there's just more to it than is immediately available. Immediately apparent. It's all immediately available. All right. God, I love this stuff. It just gets me so excited. Do we have any more questions that have come in from the group before we go into deadlocks?
So somebody's asking, can a username or ID be returned on whoever fired the action or created the action?
Yes. If you noticed, I was actually capturing that in some of the ones that that we ran before. I showed you this. I went past it. I didn't point it out, but we were capturing the NT username, the login name, and I forget what other the one, a database name. I forget.
Yeah,
database
I'm sure you were.
name.
That's from Jim. Jim's old. He is not paying attention, so it's fine. So Paul asked, the Watch Live data is grayed out for Azure SQL Database. Can he get that?
Okay, so no. It's what you have to do with Azure SQL Database to get the live data is you've got to access the you got to capture the data out and then read it from the data files. So it's actually a bit of a one-step pain in the bottom with Azure, because you have to access the data files directly. Sorry,
yeah.
But once you do that, yeah, you're fine.
Yep, so that's it. So go ahead, keep going.
Okay, cool. All right, so we've got more questions. Get back to the right place. Cool. Is there a way to capture... Oh, I forgot this was the next question. Is there a way to capture the weight statistics for a query at the same time as we capture its performance metrics? Or the slides are off. Can we capture the weight statistics? Great question. Well, let's turn off these. And yeah, if I redo this, I think I'll turn it all onto query weights. Let's start this session. Let's close this one and this one. Keeping that one open for now. Query weights. Watch the live data. And then we can run any query we want. Let's see, what queries do we have available? Let's run this one again. We go back to live data. And yeah, I think the short answer is yes. I can capture weights for a specific query. This is a beautiful thing. Now, let me point out a couple of extra little wrinkles that I've done here, because it really, really matters. Because if we were to run this, if we were running, let's go ahead and turn this on back for a second, okay? Give me 1 second. I'm just going to start it and log in. Cool. No error. Awesome. So now we've got a bunch of queries running, and they're going to run and run and run. And each one of them is going to capture the weight statistics, and that's cool. But here's a question. I want to look at one query. I don't want to look at all the queries, right? And looking at all the queries is very problematic. It's capturing a lot of data. So what do? Again, we're going to take advantage of a couple of things inside of extended events. Let me first stop this session here, just so we're not stop the live data, just so we're not being overblown with it. Let's go back to the properties again and pause for a second, because on this one, in setting up the event itself, I made a little change. Let's bring it up so we can see it. Come on. There we go. And the GUI always messes this up. In this case, what I have done is I've enabled causality tracking. You can see it right there. Now, causality tracking puts an identifier onto a session, and it puts an event sequence onto each event. And so for any given event, for any given session, it will mark the session, and it will capture the events, and it will show you the order in which those events occurred. So we can do something like this. I've got all my data here, right? 1,200 separate events all fired, and we don't know which query it is we want to look at. Well, let's do this. Let us make sure we got the toolbar up. Where's my toolbar? There we go. We're going to group by my activity GUID. So we've got the activity ID. That's the identifier for the session. And by session, I don't mean extended event session. I mean the query session. We're going to group by the GUID. And so now it's grouped all my queries up. Now, if I want to, I can take a look at each of these ones and see, well, which query is this? I don't know. I don't seem to have the query on it. Oh no. Oh, these are all external weights. This isn't even the fun query that I was looking at earlier. Where is it? 76767. There is a way to search these. I'm just being lazy. There we go. It was another RPC complete, but we'll look at it anyway. So this one's an RPC complete. It ran. You can see the extended event query that ran, but what we've got is SOS scheduler yield. And we can say, okay, well, hang on, what was the order in which these SOS scheduler yields occurred? Let's show that column in the table. And now, sure enough, we can see that the RPC completed event fired, and that was a reset that completed. And then we see the store procedure call itself completed. But in between these two, we've got a series of waits, and they're all waiting on the SOS scheduler yield. So we can see every specific wait, and we can see the order in which the waits occurred. Can we capture these for a given query? The question is, can we capture them for just one stored procedure? Well, earlier we captured just one stored procedure, right? Could we capture all the waits for a given stored procedure? Yes. Yes, it's just a question of setting up the filters and everything so that we're capturing just the information we want in the way we want it. Yeah, we can capture all this stuff the way we need to capture it. So it's just a matter of setting up the work and setting up the labor to put it all together. Yeah, weights per query, guys. Weights per query. Deadlock information. Now, I know that every one of you has already set up trace flags on your databases, because no one likes having a horrible, messy error log more than me, right? It's amazing how wonderfully your error log becomes readable after you dump all of the deadlock data into it, right? Okay, who hates the data in the deadlock error log? I do. It is horrific. It is scary bad. It is a pain in the bottom. I don't like it. So what if we wanted to capture deadlock information, but we hadn't set up the trace flags? Well, here's some great news. Let's walk through it. First up, I need to create a deadlock. So we're going to begin tran, update a couple of tables. Right. Oh, and we need to hang on one second. Not that it matters for the demo, but let's just cut ourselves a little bit of pain. Stop that. All right, so the tables ran. Cool. Let's go back over to here. And let's update those same two tables inside of a transaction in the opposite order. The classic deadly embrace. One of these two is going to get chosen as a deadlock victim. I honestly don't know which one, but one of them will be chosen as a deadlock victim here in a second or two. Come on. I did run them in the reverse order, didn't I? Yes, I did. Oh, did I forget to roll back the other transaction? I did. Hang on one second. Hang on. That's going to cause us all sorts of problems. Yeah, look at that. Silly demo person. Let's just make sure that it is rolled back. Yeah. Oh, okay, cool. Good. That's what we wanted to see. All right, so now we should get a deadlock. Oh, come on. Hang on, let's just reset. Never a deadlock when you want one, right? Silly thing. This should just work. I tested it earlier, so I probably have deadlocks available, but I want you guys to see it generate one. Just so that we're doing a good demo. Why is it blocking instead of deadlocking? It should deadlock. This should completely deadlock. This is boring code, frankly. I demo it all the time for deadlocks. Well, you stink. Huh. All right, well, I've got a deadlock in there already. Let's go ahead and stop this and ensure that the rollbacks are set so that we're not interfering with any other demos we have today. Cool. Apologies for not making a deadlock happen, because it sure should have. That's weird. I missed the transaction or something when I ran it. I don't know. Anyway, we're going to retrieve the deadlock information from the system health extended event session, because the system health extended event session captures deadlocks. Every one of your systems, 2008 and up, has deadlock graphs available now. You don't have to enable trace flags. They're already there. Now, your systems may roll over those system health information. Okay, cool. But otherwise, you've got a lot of information available here. So what do I have to do? Declare the path to find out where the path is for my system health files. I'm running on a Linux system, so I definitely want to do this because it's not going to be at C: someplace. It's going to be wherever they put it in the Linux. Then I'm going to select that path from the system diagnostic log configuration, DMV. That's going to let me get the path. And then once I've got the path, I'm going to take advantage of the XML data. And I know that a lot of people are like, oh my God, it outputs in XML. I don't care, especially in the fact it's a deadlock graph. You know what deadlock graphs are in? XML. So I'm going to pull from the location. I'm going to cross-apply with the nodes to get the XML out. I'm going to cast it as XML, and now I'm going to execute. And yes, because it's an XPath query and it's on a tiny system right here, it's not running real fast, and I left the execution plans on. Come on, hurry up. And there is my deadlock graph. Ta-da. Now, can I then take this, save it as a deadlock graph file, and open it up in the GUI so I can use the GUI and take advantage of it that way? Absolutely. You can run it that way. We're not going to, just because time and you know, GUIs, who cares? Full deadlock graph, all the deadlock information is available to me. I can troubleshoot the deadlocks from here. Do I need anything else? No. If I know a system is deadlocking, but I want to drill down, could I capture RPC start, RPC complete, statement start, statement complete, and the deadlock data and combine it all up? Yes, absolutely, I could. No reasons why not. It's just a question of defining what it is that you want when you want it. Each of the things I'm showing you today is granular, and I'm showing them to you in little chunks, but you could start combining and mixing and matching them. You can. So it's just on you guys to figure out what it is that you need the most. Let's take a look at our next query. Look, I'm happy that we can capture the performance metrics, that we can capture the, the parameter values, that we can get the weights, that we can get the deadlock graphs, and all that data is great, man. It's cool, right? It's cool. It's awesome that you're able to pull all that together. No questions asked. But we're simple. All we want is an execution count. Can you just tell us how many times the bloody query ran? Okay, let's try. That's, let's go ahead and fire up. Let's do the bad parameter sniffing query. It doesn't matter which query we run, but let's just run this one. Actually, I think it might matter. Let me just check. Yeah, it does matter. I put filters in place, so we're going to run this. Cool. Awesome. It's running. All right, we don't need the deadlock graph anymore because we've successfully gotten a deadlock. And so the nice thing about demoing ahead of time is to make sure you've got stuff in place. And I still don't know why that deadlock demo didn't quite work, because it should have. Silly thing. Anyway, let's stop this one. And let's start the query execution count. And let's watch live data. Let's give it a second. Okay, cool. It's running. RPC completed, RPC completed, RPC completed. Great. So it's capturing the execution of the stored procedures over and over again, and off it goes. So all we really have to do is sit up here and take a look at, turn on live data, and then just watch the counts here so we can see that it's been executed 60 times. And this will refresh at some point. And so that's the answer to your question. We absolutely can capture that data. Now, who thinks that I'm pulling your leg at this point? Because this seems like a really stupid way to go about this process. And the fact is this is a stupid way to go about this process. You don't want to be doing what I'm doing here. This is crazy. This is not how you would really do it in the real world. In the real world, we're going to look at a different approach. Oops, hang on. My volume went like up through the roof. There we go. In the real world, we're going to take a look at a different approach. If we take a look at this query execution count, each of the extended events has got an output. Now let's take a look at system health here. You can see, because system health has got two. It outputs to an event file, and it outputs to the ring buffer. I am outputting mine, and you're seeing the ring buffer over here. In the live data, we're seeing the ring buffer. But I'm specifically outputting mine to a histogram. Let's open up the histogram. Zoom back out, and then zoom back in. And what we're grouping on is I'm specifically grouping by a stored procedure name. I wanted to only look at one store proc, and I want to get a count of that store proc. And sure enough, I have got a count of it, because what we're doing is we're taking advantage of one of the outputs to get, and let's refresh it. And now you see it went up to 286 from 216. And if we continue and continue, it'll just keep doing more and more. This is a way to capture only the counts of events. How did I do it? That's the question. The how is actually really simple. Let's go to the properties. Nothing special in the event itself. Nothing special in the events captured even. Let's get to them though. I'm just capturing RPC completed. I do have a filter in place. Let's take a look at the filter. The filter is for the particular name. I'm filtering on one name, so I can get to that. I'm just counting the executions of one procedure. Cool. Next up is data storage. In this case, I am using a histogram. Now the histogram has got, well, it's actually hard to read. Didn't check that. That might be a little difficult for you guys to see. So what I'm doing is I'm picking an event. So I'm saying, which event do I want to filter on? Well, I'm going to filter on RPC completed. Now I know it's the only event in the session, but I'm filtering on RPC completed, and then I can base my buckets on an action or a field. Well, I picked field, and the field I picked is object name. Now I can max out number of buckets 256. You can make that go up, make it go down, and that means you can count up to 256 different stored procedures if you did not have a filter in here. But you can capture the information and capture the counts, and that's what I've done here. So let's go ahead and refresh, because this thing's still been running in the background. And now, yeah, now it's up to 527. It's almost doubled. So yeah, I can capture just the counts of the procedures. And yeah, I've got live data up here, and it's going by, and it's going to be showing me the same information, but we don't need that. That's just capturing stuff off the memory as it goes. I don't need that at all. I can ignore that completely and only read from the histogram and see that. Now that histogram could be output to a file. It doesn't have to be. Mine right now is only in memory. So if I reboot the machine, the execution count's going to restart from 0. If I do anything else to, took the database offline, took the session offline, any of those things is going to affect the count. But while that account's running, it's just going to keep counting. And that's all it does. Nice and simple. So yeah, we've got another mechanism for doing the histogram. I see the question, if the histogram demo, what if you have the same stored procedure in several databases? Can you tell them apart, or will aggregate together? If you don't filter by database, it will aggregate them all together. It's, again, there's no magic here. It's nothing like, we're not doing anything that's special per se. We're just taking advantage of what the tools offer us. But you could aggregate by both. You could aggregate by database name and capture them that way. You could, you could add in other stuff. It's not terribly sophisticated. Don't go in there looking that we're going to build some massive query to define it. It ain't going to work like that. It's pretty simple. Pick one of these, and off you go. But then it just works. So it's a great little tool. It's just an added little mechanism that we have to do more with this stuff. All right. And that is my last question that I had fielded. If you guys have more questions, I would love to hear it. Okay, is there a link available as inspiration for these extended event samples? You know what? I didn't put up a link. Give me 1 second. Keep on my screen here. Don't switch me out.
Okay.
Let me.
Well, you're going to blog about this stuff, right, Grant?
I have a blog, But there's a specific blog post I want to go to. Give me 1 second. You guys don't need to see me log in. I know people saying no demos, in presenting, never show them your blog. In this case, I got to show you my blog. It's not so much for me, it's for other people. Because I've done something with extended events and I want to share it. And I should have put it in the slides. I apologize. Give me 1 second just to bring this up real quick. So I've got a blog post called The Very Best of Extended Events. And it doesn't have any of my stuff on it. What it's got is everyone else's stuff. So Eric Darling's tool that works with extended events, William Durkin's tool that works with extended events, the DBA tools that work with extended events, Gianluca's tool that works with extended events, and then David Mason, Eric Cobb, Jason Bremhall, Aaron Stellato, Aaron Bertrand, Eduardo Pivaral, Greg Moore, Marcin Kaminsky, Schwasek, I don't have his first name, Jess Schultz, all of these people's best blog posts as picked by them, all available here. So if you go to Scary DBA 2020-0420, the very best of extended events, or just look up extended events on Scary DBA. Can you get inspiration? Yes. And this is inspiration from the best in the business. These are the people you want to listen to, not me, right? I'm promoting them because they're the ones that are doing some cool stuff, especially what DBA Tools has done with extended events and what Gianluca and William have done with extended events. And not to knock anyone, they've all done amazing stuff. But those three have done some really cool things. DBA Tools especially has got mechanisms that allow you to query extended events and bypass the XML. Woo, big win. So I would take a look at DBA Tools for that reason alone, let alone all the other great things that are available in DBA Tools. Okay, with that, I'm going to stop my screen share.